Today we're going to learn modeling with quadratics. So we're going to find a quadratic function that exactly fits 3 points, and we're going to find a quadratic model to represent a data set. So before we talk about quadratic models, let's recap how we can solve a system of 3 variables. So remember, we want to label our equations, so 1, 2, and 3. And then we want to see what variable we want to cancel out or eliminate from all 3 of these. So it doesn't matter which one we use. I'm going to get rid of all of the y's. So first I'm going to use 1 and 3. So 1 and 3. And they're already set up so that my y's are the same. They're both 2y and they're opposite signs. So I can go ahead and add them. So I'm going to get 3x. That will cancel. Plus 2z equals 16. And I'm going to circle that. Okay, I'm going to come back and use that one later. So now I have to use the second equation since I didn't use that one yet. So I'm going to use 1 and 2. And if you notice, the y's are not the same. So we have to cancel out the y's again. Make sure we cancel out the same variable. So I need to multiply my second equation by -2. So that way my y's will cancel. So the first equation will stay the same. And then my second equation is now going to be -4x plus 2y plus 4z equals -10. And I'm going to, again, add these since my y's are now the same value with different signs. So this is going to give me -3x, the y's are gone, plus 7z equals 2. Okay, so now the 2 circled ones, I'm going to put together. 3x plus 2z equals 16. And I'm going to stack that with the -3x plus 7z equals 2. And my x's now will cancel out nicely. So those are gone. And now I have 9z equals 18. Divide by 9. Z equals 2. Once I know what z is, I'm going to go back and plug that in to either of the 2 circled equations. Okay, so I'll take the first one I circled, 3x plus 2, and now z is 2, equals 16. So 3x plus 4 equals 16. 3x equals 12. X equals 4. Now that I have 2 of my variables, I go back to any of the original 3 equations, and I plug both my x and my z in. So I'm going to take the second equation, so 2x, so 2 times 4, minus y, which I don't know, minus 2 times z, which is 2, equals 5. So 8 minus y, minus 4, equals 5. So 4 minus y equals 5, minus 4, -y equals 1, so that means y equals -1. Once I have my 3 points, I'm just going to now write them as a ordered triple in alphabetical order. So 4 for x, then y, so -1, and then z. So this right here is my final answer. So we're going to use this idea to work with quadratic modeling. So when you have 3 points, we can use quadratic modeling. what we're going to do is we're going to use standard form. So standard form is y equals ax squared plus bx plus c. That's standard form. So what we're going to do is we're going to create our three equations using the 3 points that we have. So the first equation, we're going to use the first point, 1, negative 2. So we're going to plug in a 1 for x and a negative 2 for y. And we're going to keep a, b, and c the way that they are. So instead of y, I'm going to plug in negative 2. And then I have a x squared plus b x plus c. So now I have 1 squared is just 1 times a is a, b times 1 is b, and then c is c. And we're going to now use the second equation, or the second point, to make our second equation. So same idea. Negative 4 is y, a stays a, and now x is 2. So 2 squared plus b times 2 plus c. So negative 4 equals 2 squared is 4, so 4a plus 2b plus c. And then we're going to do it a third time with the third point. So negative 4 equals a times 3 squared plus b times 3 plus c. So negative 4 equals 9a plus 3b plus c. So I'm just going to order these a little bit nicer. So I'm going to say that the first equation is a plus b plus c equals negative 2. The second equation is 4a plus 2b plus c equals negative 4. And our third equation is going to be 9a plus 3b plus c equals negative 4. So once we have this, now we're treating this like we do when we have a system of 3 variables. We want to do the same exact thing as we did in the other example. So we're going to cancel out one of the terms. So in all 3 of these, c is the easiest to cancel out. So I'm going to use 1 and 2. I'm going to do this on another page. So I'm going to use 1, which was a plus b plus c equals negative 2. And I'm going to use 2, which is 4a plus 2b plus c equals negative 4. Okay, so to cancel out my c's, I'm going to subtract everything. So a minus 4a is negative 3a. b minus 2b is negative b. C minus c is gone. Negative 2 minus a negative 4 is a positive 2. And I'm going to circle this, because we'll come back to that. So now I have to use the third equation. So I'm going to use equation 1 and equation 3. So a plus b plus c equals negative 2. And then the third equation I didn't use yet. I have to use that one. So it's 9a plus 3b plus c equals negative 4. And again, my c's I have to cancel out, and since they're both positive, I'm going to subtract. A minus 9a, I get negative 8a. A minus 3b is negative 2b. C minus c is gone. Negative 2 minus a negative 4 is 2. Okay, so just like we would with a regular system of 3 variables, we're going to take the 2 that we circled and we're going to put them together. So negative 3a minus b equals 2, and we're going to stack that one with negative 8a minus 2b equals 2. So now I have to cancel something out. So I'll cancel out the b's. I'm going to multiply the top equation by a negative 2. So I get 6a plus 2b equals negative 4. And on the bottom I have negative 8a minus 2b equals 2. So now I can add these since my b's have opposite signs. So 6a minus 8a going to give me negative 2a. That's done. Negative 4 plus 2 is negative 2. So I'm going to divide both sides by negative 2. So a equals 1. Okay, so I know what a is. Now I need to go back to one of the two circled ones and plug in 1 for a. So I'll go to the negative 3a one. So negative 3 times 1 minus b equals 2. Negative 3 minus b equals 2. Negative b is equal to 5. So b equals negative 5. Okay. And then from here, I'll go back to any of my initial 3 equations and plug it in. So I'm going to use the first equation. So a I knew is 1 plus b, which is negative 5, plus c is negative 2. So 1 minus 5 plus c equals negative 2. Negative 4 plus c equals negative 2. So c equals 2. Okay. So instead of writing your answer as a ordered triple, as an ABC, these are now the coefficients for our function. So standard form, we know, is y equals ax squared plus bx plus c. So now we know what a, b, and c are. So our answer then is going to be y equals 1x squared minus 5x plus 2. So we have a, we have b, and we have c.